everyone. In this video, let's try to understand the concept of overfitting and underfitting. So, overfitting and underfitting are the two states that the model can achieve. So, basically, these two states are not desirable. So, we expect our model not to overfit. Okay, we don't want this, or even we don't want underfitting condition also. But let's try to understand what these are. So, let's try to see with respect to loss. So, we know there are two kinds of losses, right? One is training loss, which is the loss that occurred on the training data, whereas there is some other kind of loss that is testing loss. So let's try to see with respect to this loss, these two losses, how are or in which cases we say that our model is overfitting and underfitting. Okay. Now let's try to draw a graph. Okay. This graph is with respect to the number of epochs or iterations. So we'll see what these epochs or iterations. You can think of, for now, you can think of it like one time of updation of all the weights that we are having. Okay. And this is, let's say, our loss. So we have two losses, right? So I'll be signifying it with two colors. So let's say this light green is signifying about the training loss. So if we are like doing, or if we are increasing the number of epochs, what is that? What does that mean? Like we are applying this particular gradient descent multiple number of times. So our gradient descent formula is theta nu equal to theta old minus alpha times loss with respect to the theta. So we'll be adjusting these parameters with respect to all the training data points. Here, this loss is calculated on all training data points, right? So we'll be adjusting them. So because of that, what will happen? Our loss will continuously decrease like this. And after some time, it can go to zero. So this can happen if we are trying to observe the training loss. So this is regarding training loss. Okay. But if we observe the same with respect to testing loss, that is, our testing loss will also reduce till some point with respect to like how we are seeing training loss reduction. In the same manner, it will reduce till some point. But after some point, this testing loss will slowly increase. And why will that happen? Let's try to see with some example. Let's say this is my output. Okay. This is Y. And let's say we are having X. So this is my input, whereas this is my output. And let's say these are my sum of the data points, training data points for suppose. So for these training data points, let's say we are applying some algorithm, not necessarily linear regression. So we are applying some machine learning algorithm so that like we are doing like training for multiple epochs or multiple iterations. That means that we are trying to exactly fit for training data. In such case, what will happen? Our hypothesis will try to fit or try to touch each and every point. So if it touches like this, then what will happen to our training loss? So when it touches like this, what will happen? Basically, if you guys remember the loss function that we are using, that is y minus y predicted whole square. So for on each point, we'll calculate loss like this, right? So this is the actual value and this is the predicted value. Here, if it touches this point, that means that both this actual and predicted are equal. So if these are equal, then this whole error will go to zero as it is touching each and every point. So this condition we say overfitting condition. And where is we saying this as overfitting condition? According to this diagram, when we say overfitting is when the training loss is less, that means here if you observe, training loss is very less. This training loss is very less. But what happens to this testing loss? This is high, right? So when our training loss is less and the testing loss is high, we say that our model is overfitting. Okay. So when the model error or the model loss goes to zero, then we can simply say it as overfitting. Here, let's try to take some testing points. Testing points will not be same as these, right? These will be little different. Let's say our testing points are lying like this. Okay. So now the amount of error made by this specific hypothesis for these testing points is really high. But whereas for the training data points, it is like it is zero. But for the testing points, it is very high. So we say such a condition as overfitting condition. So it is not a desirable condition just because we are trying to fit for each and every point in a training data set. Okay. And similarly, there is something called as underfitting. So underfitting is like our training loss itself is very low. So here, if you observe, both our training and testing loss are very low, right? So this condition we count as underfitting. Basically, whenever we are underfitting, there is no need for us to check for this testing loss, because if training itself is not getting performed well on training data itself, it is not getting performed well. Why we go and check on testing data, right? So that's why we will not be caring that much about testing loss in case of underfitting condition. Okay. And when we say our model is really good, so let's say in this case, if we stop, in such case, our model, we say it as very good model. That is because our training loss and the testing loss are reasonable. So if we can see with respect to the diagram, so we can say that this is some overfitting condition. And let's say there can be some line like this, which is near to most of these points. So this, you can think of it as good model. Okay. And let's say we are having some random line like this. So let's change the color. So let's say we are having some random line like this for these points. Then we say this is underfitting. So this model is underfitting. So like this, we can understand the concept of overfitting and underfitting with respect to loss. And similarly, the same thing we can understand with respect to score as well. So if you guys remember, in the last video, we have discussed R to score. So let's say this is our score. And in score also, we have two things, right? One is training score, training R to score. And similarly, we have testing score, right? So there are two things. One is training score and testing score. Okay. So, and this is, let's say, the number of epochs. And if loss increases, what will happen to the score? Score will decrease, and if loss decreases, score will increase. In general, this is the thing that will happen, right? So we can interchangeably think of them as increasing and decreasing, or inversely proportional, this score and loss. So this score and loss, we can think of it as inversely proportional. So what will happen? Initially, our score for training data will be very less because our model is not yet trained. So after doing it for multiple epochs, my score will slowly increase like this, and my score will try to reach to 1. Okay, so this is corresponding to training score. Okay, so this is our training score. Now let's try to observe the same with respect to the testing score. Our testing score will slowly increase till some point in time. After that, it will slowly reduce like this. So we say, like this green is our, let's say, our testing score. Then we say this condition, that is this portion, we can say it as it is overfitting. Why is that? Because our training score is really high in this case, whereas our testing score is less. And similarly, here we say our model is good model. Okay. And what we say over here, we say that here it is underfitting. Okay. Like that, we can understand the concept of overfitting and underfitting with respect to either R score or even with respect to the loss. Okay. And there are two concepts. Okay. So whenever you come across the concept of underfitting and overfitting, you will be coming across these two terms, that is bias and variance. Now let's try to understand these as well. Bias is nothing but error. Okay. And what is this variance? Variance, you can think of it like the amount of like variation that is shown by the hypothesis with the changing training data points. Okay. Let's try to quickly understand some small example. So let's take this example only. So if you are having an hypothesis like this, which is changing for each and every point. So here if you observe, this hypothesis as having so many terms like this, right? And that is changing for each and every training data point that we have. So we say it has more variance. That means it is varying for each and every data point. So we say our variance is high in such case. So by understanding these two bias and variance, can you guys quickly comment in the chat what will happen if we have more bias and what will happen if we have more variance? So maybe in the next video I'll be telling about like when we say that it is underfitting and when we say that's overfitting. So can you guys please comment in the comment section? So what should be high for overfitting and what should be high for underfitting? Okay. So basically, for some good model, both both these bias and variance should be some good values. It means that these should not be very high. Okay. So these should be some good values. Okay. So this is the concept of underfitting and overfitting. So if you have any doubts, you can comment down in the comment section. And thank you everyone. Bye bye.